Alright, welcome to this edition of Comet Algebra. Today we're looking at section 1.3, Simplifying Expressions with Exponents. So we need to do a quick review of the properties of exponents and define a few terms. So hope your summer packet's going well. So have it open to the page that's entitled section 1.3. There's a chart at the top with a summary of the properties of exponents. So let's just review these quickly. If you are multiplying like bases, if you have x to the fifth times x squared, if you expanded these, this would be an x used as a base 5 times, this would be x used as a base 2 times, so altogether you would be multiplying x by itself 7 times. The shortcut we use is that when you're multiplying like bases, you add exponents. So very similar to that, when you are dividing like bases, if we have x to the third and we're dividing by x to the 11th, yes, you subtract exponents, and the question is how many are left and where are they located. If you expanded this numerator out, it would be x times itself 3 times. The denominator would be x times itself 11 times. So if one of these x's on top canceled out one of these x's on the bottom, you would have 8 x's left on the bottom, or x to the 8th power, and it is located in the denominator, so the answer would be 1 over x to the 8th. The next property talks about when we have a power raised to a power. So if we had x to the 4th and we were taking this whole parentheses to the 3rd power, that would mean I'm using x to the 4th as a factor 3 times. So that's a lot of x's if you count them out. 4, 8, 12, there'd be 12 of them, and so the shortcut we use, the property says, when you have a power to a power, you multiply exponents. Alright, the next property is when you have something in parentheses and you're taking the entire parentheses to a power. So say I had 3a squared b to the 5th, and I was taking this whole entire parentheses to the 3rd power. If you recall, that means you have to take each piece, each factor in this parentheses has to be raised to the 3rd power. So I have 3 to the 3rd power, 3 times 3 is 9, times 3 is 27. A squared to the 3rd, that's a power to a power, so we multiply exponents. And likewise with b to the 5th to the 3rd power is b to the 15th. Anything you take at all, anything to the 0 power. If I had 7x to the 5th, y to the 8th, and I was taking that to the 0 power, anything to the 0 power is 1. And if you remember, we went over that in Algebra 1 because it fits in with the pattern. All right, and then this last one on the table here is negative exponents. Quick review of that, we talked about KFC, which does not stand for Kentucky Fried Chicken. The K stood for keep. In other words, you keep the positive exponents where they are, don't change their location. The F stood for flip. Anything with a negative exponent, if it's in the denominator, it flips to the numerator and vice versa. And then the C, well, sometimes we said it stood for combine or change, or because you often then can combine your like bases. So let's look at a quick example of this. Alright, in this example I tried to combine some of these properties. So let's see if you remember how to do this. Both of these have parentheses raised to an exponent, so we have to take this squared and we have to do that to the 4 and to the x to the negative 3. So 4 squared is 16. Multiplying, we have a power to a power multiplying exponents. We have x to the negative 6th. Likewise down here, both of this x and y need to be raised to the negative 4 power. So I have x to the negative 4 power and y to the positive 8 power. So we've taken care of our power to a power. Now we do our keep flip. The 16 does not have a negative exponent, it will stay. This x to the negative 6 will flip down to the denominator. This x to the negative 4 will flip up to the numerator, and the y to the 8th will stay where it is. Now after we have finished our keep flip step, now we combine our like bases. The only like bases I have are these x's, so we just subtract exponents. There's x to the 4th up here, so there's 4 x's. These 4 cancel out 4 of these, or you can think of it as subtracting. So I'm left with x squared y to the 8th in the denominator. All right, next is a review of some terms that I hope you remember. First, the word coefficient is just the number in front of the variable. An example of this, if I had 4x squared y, the 4 is the coefficient. A monomial is a single term expression. My example here for coefficient, 4x squared y, is a monomial. Terms can only be separated by plus and minus signs, so when these are connected by multiplying, this is a single term. A polynomial is defined to be one or more monomials, so a polynomial is like many. So if we had like x squared plus 3xy plus y squared plus 7, that would be a polynomial because it's made up of 4 terms. Then binomial, that prefix bi meaning 2, it's a polynomial that's made up of 2 monomials. So an example of that would be like 3x squared plus 4y. And then the last one we want to define is a trinomial. And of course, trinomial, the prefix with tri meaning 3. So this is a term that has 3 monomials in it. Like x squared plus 4x minus 7. Okay, next term we need to know is degree. The degree is the highest exponent. In this example, the highest exponent is a 5, so we would call this a 5th degree. And that, of course, is a trinomial. It's made up of 3 terms. My second example here is a monomial, and this is a 3rd degree monomial because the highest exponent is a 3. Now I need to quick review what like terms are because you can't forget basics like this. Like terms are ones that have the exact same exponents and the exact same variables. And as you recall, you can only add and subtract like terms in algebra. All right, next let's look at a few examples just to help get you some practice. So in example 1, I'm asked to simplify these, so I am multiplying like bases. Don't forget you multiply the numbers just like you always have. 4 times negative 3 is negative 12. Now I'm multiplying the x's, like bases. Multiplying like bases, we add exponents. Negative 2 and positive 2 is 0. And then with my y's, if I add 1 and negative 4, I get negative 3. So now we have 2 things to simplify here. This y to the 0 is just a 1. And this y to the negative 3 needs to flip down to the denominator. This negative 12, however, does not have a negative exponent. It just sits there and stays in the numerator. And then that's your final answer. All right, in this next example, we're dividing like bases. But before we simplify them, I want to do the keep flip step. So everything in the numerator is a keep because it has positive exponents. And the only thing down here to flip is this x to the negative 1. So we're going to flip that x to the 1 up to the numerator, and that then we'll be done with the keep flip part. And so we'll move right into dividing these like bases. So first of all, multiplying some like bases with these x's, I end up with an x to the 5th. This is a y to the first power when there is no exponent, so this y takes out one of these. So I end up with a y squared in the denominator. And this z to the 5th is combined with this z to the 7th on top. 7 take away 5 is 2, and the z's are in the numerator, so we need to leave them there. So the final answer is x to the 5th z squared all over y squared. All right, this last example, we are taking everything inside this inside this parentheses to the exponent of 2. So if you'll recall, negative 2 times negative 2 is positive 4. And then I just have a squared, c to the 8th, over 25, b to the 6th. And just checking it for any more simplifying, I cannot reduce this fraction of 4/25, and there's no like basis to combine, so this is the simplified answer. All right, this one last example is showing you about combining like terms. So this first term is an x squared term. I can combine it with this other x squared term, and I just noticed here that I am adding all these. So 3x squared plus 5x squared is 8x squared. Now I have an x term, so I search over here and I find another x term. So I can combine those. Positive 2, negative 3 is a negative 1x. And then the last things I can combine are my negative 8 and my positive 9, and I get plus 1. So this trinomial is the answer after we combine like terms. All right, now you have all the knowledge you need to finish page 1.3 of your summer packet. I mean, are we having fun or what?